Hi, my name is Kelsey Cameron, and in this video I will talk about IP datagram fragmentation, what it is, why it matters, why it's necessary, and an example problem of what we can do with it. So, you probably don't know what fragmentation is. If you do know, please correct me if you notice any mistakes in this video. Hopefully there shouldn't be many because I've been studying a lot. So, IP fragmentation. I would say that IP fragmentation is breaking up packet data so it can fit through a particular network. Please excuse my bad handwriting. I've discovered that this has some audio issues. I'm going to try. So I'm hoping this video will turn out. Breaking up packet data so it can fit through networks. So, based on that definition, IP fragmentation, breaking up packet data so it can fit through different networks. Why does it matter? Well, every network is different. Some networks might have a maximum transfer unit of, say, 6,000 bytes or something like that. Or some of them might have a max transfer unit of 2,000 bytes. Some of them might have a max transfer unit of 1,000 bytes. So what if my data is 6,000 bytes long, but I'm trying to send it through a network that can only handle 1,000? What do? Well, I break it up into chunks. I send it one chunk at a time. And when I do this, it doesn't actually necessarily arrive in order, but TCP takes care of that rearranging at the end destination to place all of those fragments back together and to allow you to recover the data. So I'm going to give an example here. This problem that I'm looking at. It's important to keep in mind something I didn't even realize when I did this problem, but I learned from making the mistake. When you are working with fragmentation, remember that TCP has a header that is 20 bytes long. That matters because the fragmentation will change because of that header. So TCP header is 20 bytes. If you forget that, then you're not going to divide it up correctly and all of your fragments are going to be wrong. That's what happened to me, but I learned from it, so no problem. So consider an IP datagram that has 6,000 bytes total. And the MTU, max transfer unit, can only support 2,000 bytes at a time. The question states, for all fragments, show the length and offset fields. So show length and offset. So, at first glance, if you forgot about the headers, you'd say, oh, that's easy, 6,000 divided by 3. Then you'd have 3 fragments, 2,000 each. Well, no, that's not correct. It's not correct because for each fragment, you need a header. Anytime you send anything through TCP, you need a header. And this header is 20 bytes. So, I'm going to create a new page and explain that in greater detail. Here we go, 6,000. So, I know that I can send a maximum of 2,000 each time because that's the MTU. So that's my max. I want to send as much as I can as quickly as possible. People like fast data, they don't like slow data. So I know that the header is 20. So 2,000 minus 20, that's 1,800. That is how many I'm sending with each fragment. How much data I'm sending through each fragment. I'm sending the 20 byte header and then an 1,800 byte fragment. It's all connected. So if this is my fragment here, this whole thing is 2,000 because that's my MTU size. 2,000. And here's my header, header, and then my data. So this would be 20, and then this would be 1,800. So the screen go? So now I'm going to draw the different boxes. So if my data can only be broken up into chunks of 1800, how many chunks do I need to support 6000? Well, one chunk would be 1800, two chunks would be 2600, three chunks would be 4200, and then I'd need one final chunk after that. Hopefully I said that math correctly. But so fragment 1, so I know that I need a total of 4 fragments to break it all up, because the header will cause me to not send as much data as I otherwise could have, and then I will need an extra fragment for it. So if I'm going to have the length field and then the offset field. Yeah, I've always wondered how people draw straight lines, because I can't. I seriously, I'm also holding this in the air, so my apologies. Let's say that the left side is length. Come on, go away, header. Length. Man, I don't know why this thing keeps popping up. And then this is offset. And another important thing to mention is that the offset is in terms of 8 bytes. I honestly don't know why this is, but that's just how it's stored, in terms of 8 bytes. It's very important to remember that too. So my length. I know that my IP length for the first fragment is going to be 1800, because the MTU says that the most amount that I can transfer in this packet, or in this fragment, is 2000, and 2000, oh whoops, wait a second, my math is off here. You're probably laughing at my previous subtraction. Man, sometimes I can do math great, and sometimes it just doesn't work. Okay, 2000 minus 20. I'm sorry about that, guys. 0. That's 198. 1980. I don't know why I kept thinking 1800. Yeah, sorry about that. Anyway, so 2000 minus 20 is 1980. So that means that's the most amount that I can transfer, and I still need 4 fragments, because 1980 plus 1980 plus 1980, and then plus whatever remains after that. Because you can see how if you have a header of 20 bytes in each of these, and only 1980 can be transferred, you need 4 fragments to split up 6000. It's just division. It's basically 6000 divided by 1980, rounded up. So my length here is going to be 1980. But what is my offset? My offset, well, this is the first fragment. So the offset will be 0, because that's where it starts. It starts at 0. And then my next length is going to be, so we know that we sent 2000. So the next length should be, the length is just the total size of the data. So the length should just be 1980 again, and then 1980 again. And now I'm going to use my phone for a calculator to get some subtraction going on here, because I don't like doing this stuff in my head, honestly. 6000 minus 1980 minus 1980 3 times. So that means my remaining length for the last fragment is 60. Yep, because 1980 plus 1980 plus 1980 plus 60 is 6000. So that makes sense. Now what about my offsets here? Well, my offset's in terms of 8 bytes, so that's going to make quite a large difference, and that's something that I missed the first time, but I learned from it now, thankfully. But honestly, different teachers will have different requirements for this. My teacher mentioned that he'd accept either way, which is pretty nice. So just figure out what your teacher wants, but know that in the real world it's expressed in 8 bytes, and that's basically the way to go. So now for the offsets, I'm going to be expressing these in 8 bytes, because that's just the way that I think it should be done, too. So for each of these offsets, I know that I have to start at 0 for the first offset, and the second offset starts at 1980. But include the endpoints as well. So why this starts at 1980 is because first you're sending 1980 here, and that's from 0 to 1980, so, or 0 to 1979, because you start counting from 0. So this would be 0, 1979, and I can't type or write, come on, 1979, yeah. And then 1980 is where the second fragment starts, 1980 until 1980 plus 1980 minus 1, because it starts from 0. So 1980 through 3959. And then this starts at 3960 plus 1980 minus 1, which is 59, 5939. And then this is 5940 through 5979. That should be a 9. And the reason that works is because first you're sending 1980 bits, and then you're sending 1980 bits, and then you're sending 1980 bits, and then you're sending 60 bits. Counting starts from 0, so 0 through 1979 is where the offset. The offset starts at 0, and then all of those values all the way up to 1979 are used for that data. And then from 1980 to 3959, and then 3960 to 5939, and then 5940 to 5979. Notice that last one is only 60 bytes, not 1980, and that was because 6000 minus 1980, minus 1980, minus 1980, minus 60 equals 0, or in an easier way to understand, 6000 divided by 1980 is 3 point something, and you have to round up. So that means you need 4 fragments. So I hope that this makes sense, and if you have any questions about this, feel free to ask. I probably will be creating a few more of these videos just for adding resources to YouTube. I've noticed there's not a whole lot out there explaining these types of subjects. Anyway, I hope you have a great day, and I hope you enjoyed this video.